So I have one last example, and this one's using the beaker method again, but I'm using it not with mixtures, well, sort of a mixture, but this one involves a lot of coins. This is to demonstrate that these two methods are flexible, and you don't always have to use them with just a pure mixture or even just with, distance and motion and travel, that they still can apply to a lot of other types of problems. So this one says a man has $2.55 in quarters and nickels. He has 9 more nickels than he does quarters. How many nickels and quarters does he have? So we have to figure out, what the two are mixed together. It's kind of like a mixture problem, so that's why we're going to use the beaker method to attack it. And again, the two things that I'll try and keep track of is how much of quarters and nickels do I have, and what would the amounts of each of these be. So I guess better label my beakers. That'll make it a little bit easier. We will say that this first one contains just nickels, and the second one contains quarters. All right, nice. Let's see what we know about the nickels. So he has 9 more nickels than quarters. So we don't know a whole lot about those quarters, do we? So the amount of quarters, we'll leave that as X. And the amount of nickels, well, there's 9 more than however many quarters he has. So X plus 9. Let's see. Now I can write down the what each of them represents. So a quarter be 0.25 and a nickel 0.05. Now what we're looking to do is, combine these together, the amount and how much each of them are, to get a total amount in that last beaker. He has a total of $2.55. Now the reason why I'm not writing down a specific amount or a specific amount per coin in there is because this one represents the two already put together, so just the $2.55. All right, let's go ahead and build our equation. So 0.05 multiplied by the amount, x plus 9. 0.25 x equals $2.55. Well, this one's similar to the previous one. It has lots of decimals running around, and I want to, get rid of a lot of those decimals. So I'm going to multiply this one by 100 so that we can deal with just some nice numbers and no decimals. This would make it 5 times x plus 9 and 25x equals 255. So that's the equation that we'll solve and figure out how many quarters and nickels we actually have. $5x plus 9 plus 25x equals 255. Okay. So working to simplify this equation, I'll distribute through on the left side of the equation, giving me a 5x plus 45. Okay, now I'll go ahead and combine my like terms. So 5x and 25x, that would give me a 30x. Looks good. Okay. Subtract 45 from both sides so you can get that x a little bit isolated. And finally, let's go ahead and divide by 30 to see if we can figure out what that x is. So x is equal to 7. Now, into the context of this problem, well, x represents the number of quarters we have. So we have 7 quarters. Now, if you remember, we have exactly 9 more nickels than quarters, so we can add 9 to this number and figure out the total nickels. We have 16 nickels. All right, and now we've figured out the total amount of both coins. So In each of these types of methods, they're really just a great way so you can get your information organized and into a good spot. Remember that they're really handy with motion and with mixtures. Thanks for watching Educator.com.